Solution to a system of linear equations. We are given a system of linear equations. It can be solved by a method known as matrix inversion method. But this method is applicable only when the number of equations is equal to the number of unknowns. So here two equations are there, two unknowns are there. Now the given system of equations can be written in the matrix form like this. Here coefficients are 5 and 2, 3 and 2. So this is the coefficient matrix 5, 2, 3, 2 coefficient matrix. Solution set is x, y, then constants. Suppose here every numbers are 0, then it is called homogeneous equations. Now this is a non-homogeneous equation. But the matrix inversion method is applicable only if this matrix is non-singular. That means determinant of this matrix should not be 0. 5 into 2, 10 minus 3 into 2, 6. So 10 minus 6 is 4. So determinant of this matrix is 4. Now the system of equation can be written as Ax is equal to B, where A is the coefficient matrix, X is the solution set and B is the constants. Now Ax is equal to B. So since it is a non-singular matrix, for A there is an inverse. So multiply by A inverse on both sides. A with its inverse will be identity matrix. X into identity matrix is X itself. So this side it is X. So X is equal to A inverse B. So we can find the solution set by this equation. X is equal to A inverse B. Now we have to get the inverse of this matrix. Already you know how to get the inverse of a matrix. Inverse of a matrix is adjoint A divided by determinant of A. Determinant of A is 4. Then this is the adjoint of A. So A inverse is 1 by 4. Then this 2 minus 3, 5. Then as per this equation, X is A inverse B. So X solution set X, Y. A inverse is this matrix 1 by 4, 2 minus 3, 5. Then B, this constants 3 and 5. So now you multiply this matrix. 2 into 3, 6 minus 2 into 5 minus 10. Then this with this minus 3 into 3 minus 9 plus 5 into 5, 25. So now 6 minus 10 is minus 4, minus 9 plus 25 is 16. So take this 1 by 4 inside. So here it will become minus 1, minus 4 divided by 4 is minus 1, 16 divided by 4 is 4. So now you are getting the solution for this. X is equal to minus 1, Y is equal to 4. So we can apply matrix inversion method when this is a square matrix and it is non-singular. Using matrix inversion method, let us solve a system of linear equations with 3 variables. Now 3 equations are given and 3 variables are there. So this given system of equations can be written in matrix form like this. Here coefficient matrix 2, 3, 3. Next 1, minus 2, 1. Next 3, minus 1, minus 2. That is the coefficient matrix. Then the unknowns x1, x2, x3 and constants. Constants are 5, minus 4, 3. So the given system of equations can be written in matrix form like this. Then it can be represented as Ax is equal to B, where A is the coefficient matrix, X is the matrix with the unknowns and B is the constants. Then when we see the determinant of this matrix, it is 40. It is not equal to 0. So this is a non-singular matrix. So if this is a non-singular matrix, we can find the inverse of the matrix. So how to find out the inverse of matrix? I have already explained in a previous video. So I am not explaining that once again. Inverse can be got like this. 1 by 40, then 5, 3, 9, 5 minus 13, 1, 5, 11 minus 7. Then the solution is given by this formula. X is equal to A inverse into B. X is the solution set. Then A inverse is this matrix and B is the matrix of this constants. Then multiply these two matrix. So you will get this. Then take this 1 by 40 inside. 40 into 1 by 40 is 1. 80 into 1 by 40 is 2. Minus 40 into 1 by 40 is minus 1. So comparing this, x1 is 1, x2 is 2, x3 is minus 1.